In section 5.2.29, the data on the right represent the number of live multiple delivery births, 3 or more babies, in a particular year for women 15 to 54 years old. We're going to use the data to complete the parts A through D below. So here's the age group, here's the number of multiple births, and then there's the probability. And so for part A, we want to determine the probability that a randomly selected multiple birth for women 15 to 54 years old involved a mother 30 to 39 years old. So what we're going to do is we're going to be able to then find, the probability of 30 to 34 and the probability of 30 to 39. So if we take a look at the chart here, we have 30 to 34 and 35 to 39. And if you notice here is that the probability for 30 to 34 is 0.382 and the probability of 35 to 39 is 0.250. Now they showed you how they got the problem or the numbers to begin with. That means if you add up all these numbers, a total is 7366, and we're taking 2817 divided by 7366 to get that probability. And so therefore, we're going to plug that into our formula going from probability of 30 to 39, and if we add those two numbers together, 0.382 plus 0.250 give us 0.632. Now in part B it says determine the probability that a randomly selected multiple birth for women 15 to 54 years old involved a mother who was not 30 to 39 years old. So in this scenario what we're doing is we're trying to find out what is the complement of that event. So we're trying to find the probability that it's not 30 to 39. So since we already found that the probability from 30 to 39 is 0.632, then we're going to take 1 and subtract 0.632 to get the complement. So therefore, the probability that a randomly selected multiple birth for women 15 to 54 years old involved a mother who was not 30 to 39 years old is 0.368. And in part C, it says determine the probability that a randomly selected multiple birth for women 15 to 54 years old involved a mother who was less than 45 years old. So what we want to do is we're going to use the complement rule to yield the following equation. The probability that it's less than 45 is equal to 1 minus the probability that's greater than or equal to 45. And so if you take a look at the probability that it's greater than or equal to 45 is down here, which is the final column. And that column, which is greater than or equal to 45, is 0.017. So therefore, we would put that into our formula. We would say that the probability that it's less than 45 is equal to 1 minus the probability of greater than or equal to 45. So we take 1 and subtract 0.017, which gives us 0.983, which makes sense because that means that this entire list of probability that's less than 45 should give you approximately close to 98% according to the probability for 45 to 54. Now in part D it says determine the probability that a randomly selected birth for women 15 to 54 years old involved a mother who was at least 40 years old. And we're going to interpret the result and then find out whether it is unusual. So in order for us to find the probability of at least 40, well that means that we're looking at least. So if it's at least 44, 40 to 44, we can't go anywhere below 40 and 44, but we have to include everything above it. So the probability of 40 to 44 is 0.049, plus the probability of 45 to 54, which is 0.017. When we add them together, we get 0.066. Okay, now, and then to determine whether it is unusual or not, we have to compare it to see whether it is less than 5%. Now for this example, they choose to multiply this about 1,000, but you don't have to do that. You can either take the actual result that we got, which is 0.066, and we can see that it's greater than 0.05, which is 5%, excuse me. And because it's greater than, not less than, then that means it's not unusual. Likewise, if we wanted to compare it just to 5%, we can take 0.066 and multiply it by 100 to give us 6.6%. And again, that's greater than a 5%. Therefore, it is not unusual.